So we're going to talk about this so-called concept of capacity. Capacity. And because in operations management, we need to think about, what constrain the organization or the company to deliver their services. So we have capacity. For example, you go to restaurants, it has 30 sittings. So that is capacity. 30 seats. If you go to a theater, a big theater, or you go to the Tokyo Dome, so these are, every facilities have design capacity, has effective capacity. We look at some of the concepts, okay? We look at some simple concepts about capacity. I'm not going to cover much on this. This is probably at advanced stage. So I just want you to focus on capacity, break-even analysis, these two things, these two main things. The rest I'm just going to briefly explain, not in detail. And also this expected money. No, I'm not going to explain this because this relates to capacity as well, but not here because this comes into some financial decisions. Okay, I'm not going to cover that. So basically two things. One is capacity, right? And also define capacity, what is capacity, and then design capacity. I'm going to teach you about this, and not much on bottleneck analysis. Little bit only, it's okay. Bottleneck, little bit only, but not much. And today I'm going to teach you how to calculate break-even analysis. Okay, we have a method that is used to do some analysis to determine our break-even. Okay, you have studied it before. It's okay. Huh? Okay, no, I'm not going to cover that. Okay, capacity. What is capacity? Capacity is the throughput or the number of units that any facilities can hold. This is a concert hall. If the concert hall has 1,000 capacity, well, that is the capacity, because it will determine how much you can get income to the organization, revenue. Aeroplanes, I mentioned last week, Airbus 350 has 300 plus capacity. Okay, 777, I think is 500, more than that. So these are throughputs. Throughput means how much you can actually produce, how many you can serve, how many customers in the concert hall, or even stadium, baseball stadium, football stadium. Okay, for a period of time during the service or during the you get the service. That is service, but also production. In companies producing car, what is the capacity? Capacity means the equipment will be able to produce throughput 100,000 units a year. For example, this is a factory in Malaysia, for example, 400 cars per year capacity. But it doesn't mean that it can produce 100,000, because sometimes it has problems. It has issues. So this is the design capacity. What is the effective capacity? So that is another question, okay? And also, it will determine your fixed costs. If you want more output, you have more machines. More machines, more fixed costs, okay? So that is another important issue. And also, it will determine if demand can be satisfied. Because if demand from customers is more than 100,000 a year, you will not be able to meet the demand. Okay, so you need to think about long term. So these are strategies to increase capacity. Okay. Okay, so there is this three time horizons. Short term, medium term, long term, capacity planning. So we talk about capacity planning, okay? So planning over the time horizon, that means we talk about long range. So what is the options for adjusting capacity? Means how to increase, especially if the demand is high, long term, expansion, more companies, more population. So you need to add facilities. You need to add long lead time equipment, meaning there are equipment that require a lot of longer time. But today, because of rapid technology, because of digitalization, computer aided design, so it's shorter now. Okay, lead time shorter. It has reduced, but still you need to plan. This is called long term. Long term, okay. Or if you want to adjust capacity in the intermediate term, that means it is say, for example, 1 year to, normally long range is more than 3 years, okay, more than 3 years, more than 2 years, long range. But now, because of COVID, we are facing difficulty to do planning actually. Do you agree? Because of COVID, we are having difficulty trying to, let's say, for example, plan 1 year ahead. We cannot plan 1 year ahead because it's there's too much uncertainty. Okay, too much uncertainty. But still, you need to plan. You need to think forward. I read a report yesterday about some countries already opening up. So there will be a big economic boom after this. Because now, because everybody is locked down, there is no less demand for flights, for travel. And when you open up, there will be demand, big demand. People will start to travel from, Malaysia to Japan, to USA, from China to US. So there will be a boom. So now everybody is having low capacity because of COVID. So it is like everybody is here now, short range, very short range. So when there is a jump in capacity, for example, say in 2021, the demand is only say 100,000, okay, flights or passengers. Suddenly in 2022, say it becomes fivefold, 5 times, fivefold, fivefold, 5 times, say 500,000. So sudden, so very rapid change is going to happen, rapid, okay? So there's a challenge actually going to happen in 2022 until 2023, 2024, 2024 will be a big, a jump. So this is something that companies will have to think. Operations have to think about operations. Okay, so you do this. Add subcontract. These are modifying only. You need to modify. This is use capacity. This is the thing that actually add personnel, build or use inventory. If you have inventory, if you keep inventory. And short range is just scheduling. This is a simpler planning, simplest. So capacity already fixed here. This is fixed. Cannot change. So you only use the capacity. But when you go here, you need to modify. Okay. So that is the planning horizon that everybody must understand and see how you can actually increase that. Okay. That's why companies, for example, they get new factories. Why they buy new factories? Because they want to increase their capacity. Understand? So that is the reason. So we come to the concept of design capacity, effective capacity. Okay, design capacity. So just now, when I say the concert hall, the number of seats is say 1,000. So that is the design capacity. Or aeroplane, 400 seats. Maximum theoretical output. Sometimes it's expressed as rate as well, rate 50 per hour, 90 per hour in production, But in flights, okay, you can say per aeroplane or different type of aeroplane. Effective is, so this is different design. This effective is the capacity that the company expects to achieve given some constraints. For example, in company, machine breakdown. For example, you need to reduce the speed of the machine. So instead of, for example, you can produce 1,000 per day, because of maintenance, because of delivery of parts, maybe you only effective capacity is only 800. Okay. So you can only meet this demand. So you lose 200 actually. So this is unutilized capacity, which is basically lost income, basically lost opportunity loss. Okay. So this is an example, just an example. 100 per day, 800 because of your constraints. Okay. So that is it is normal. It's common that design capacity is the theoretical output, and normally, of course, it's lower than design capacity. You will never get effective capacity greater than the, of course, design. Effective normally less than design. Okay. Now we look at this measure. Okay, this is a measure of so-called utilization and efficiency. What do we mean by utilization? Utilization means how much is used, how many percent is used. Okay, so how many percent is used? So utilization is the percent of design capacity actually achieved. Actually, you obtain. It's a real one. Okay, utilization. But it does not come up into another concept, which is efficiency. There's two different things. One is utilization. So it is given by a formula. It's a formula. Utilization is given by actual output divided by design capacity. Okay. And efficiency is the percent of effective capacity actually achieved. Okay. Effective actually, we'll see an example after this. There is an example. So you just use this formula. Efficiency is actual output divided by effective capacity. Okay. Because we have this effective capacity just now, right? Effective capacity. Effective capacity is the, after all the, deduction of constraints. Deduct the constraints. Okay. So if you can open your book, you can see the example, given. Because when we read here directly, probably I need to explain the background. Now, it is a company producing a sandwich. So a sandwich shop provides healthy, bakery. A bakery has what do you call actual as a plant for producing breakfast, this product, okay, breakfast rolls. So the breakfast rolls, and they want to know the capability. So this is a very good, simple way of analyzing any operations. Okay, you just get they get the numbers of the number of products produced. Okay, last week the company produced 148,000 rolls. So this is the actual production of last week. Okay, last week they produced 148,000 rolls. Now, the effective capacity, okay, is 175,000 rolls. Okay, they have done some calculation and they have deducted from the design capacity the maintenance time and so on. So their working hours, for example, okay, working hours. So they said the effective capacity is 175,000 rolls. But the design capacity, I mean the machine itself, the machine can run if they don't break down, if they don't, there is no spoil, okay, there no damage, they can produce 1,200 rolls per hour. Okay, so this is the condition. And the bakery works 7 days a week. 3 8-hour shifts. Okay, that means they work 3 shifts, 8 hours. Okay, that is the in terms of total hours. So from here you can calculate the number of hours that they work per week. Okay, that means the number of hours, because we want to know the design capacity total for per week. This is per week. Per week. Okay. So from here only, then we can calculate the utilization. Okay, what is utilization? What's the formula just now for utilization? Previous slide. Utilization is actual output divided by design capacity. Okay, so from here we can actually calculate utilization to be 148,000 divided by 201,000, which is actually, hang on, okay, 73%. So what does 73% means? What does 73% means? It means, that means it is only 73% utilized. It is only 73% utilized. 27%, 26.6%. Sorewa tabun ne, muda ne. No money ne. Bukannya moratinai ne. So not so good. But efficiency, okay, this is better measure. This is a better measure because we are talking about effective. Most companies or most organizations, we cannot achieve design. Design is theoretical. Design is theoretical. So we're talking about 85% efficiency, which is quite high. Okay, it's quite high. 85% efficiency. Okay. Any questions? Any question? I think, never mind. After this, I will give you one small exercise for you to just try to do so that you can understand the concept better. Okay. So this is in terms of the, basic calculation of utilization efficiency related to capacity. Okay. Remember, this is capacity and measure. So you can measure any operations, any small 7-Eleven or, a shop, bakery, udon shop, any, you can measure this, okay? Now, let's see the next example. So the next example is, the question is this, okay? The question is, the manager of this company wants to increase production of their deluxe role. Okay, so so she's going to actually add a new line. Okay, the problem says that the second line has same design capacity. So she has two lines now, one production line, second production line. And effective capacity is 175,000 rolls. Okay, so this is same design capacity, the same so-called what do you call design capacity. Okay, so it says the same design capacity, effective capacity is 170,000 same. However, but the new workers, okay, because of inexperience, they are expected to reduce output to 130,000. Okay, it says here, okay, it says here 100,000 compared to 148,000. Well, it says there 131,000. It's okay, never mind. So it is expected to reduce output to 130,000. That means the first production line is 140,000. The second production line is 130,000. And the utilization is what do you call 70% and also 84% respectively on the first line. Determine the new utilization and efficiency. So the question is actually trying to calculate the new utilization. Okay, the new utilization value and also the efficiency value. Okay. So this is actually the question. Determine the new efficiency of the second line. You understand not second line? Second line means another production line. You understand? This is one production line. With the same machine, you copy and make the second production line. So first determine the new design capacity, effective capacity, and actual output after adding the second line. Then using the same equation to determine, use equation 7.1 to determine utilization and equation 7.2 to determine efficiency. So the design capacity is going to be 201,600, okay, because its design capacity is 201,000, okay, 201,000 times 2. So the design capacity is 201,600 multiplied 2, because we have two lines. This is the design. Effective is also multiplied by the two lines. 175,000 times 2, which is 350,000 rolls. But the actual output, because it mentioned just now that the first line is more productive than the second line. So you add the total 140,000 plus 130,000. So the total being able to produce is only 278,000 rolls. Okay. So you see here the utilization is only 68.95% compared just now 74% or 76%. Efficiency has dropped from 85% to 75%, 79%. Okay. So although this adding of equipment increases capacity, it increases capacity definitely, but equipment may not be operated as efficiently with new employees because of experience. Okay, so that is, I mean, after 1 year, 2 weeks, you know, there is so-called learning curve. You have heard of learning curve? Learning curve. That means you will start to produce, you know, probably after 1 month, this may become 148,000 because of experience and knowledge. Okay, so it's a matter of time. But initially, there will be a drop in efficiency. Okay, so for Sarah James Bakery, a doubling of equipment investment, you add new line, you're actually investing, you have to pay, you have to buy the equipment. Okay, a doubling of equipment investment did not result in doubling of output. Okay, other variables actually bring down the utilization. Okay, so you can do a lot of things. Okay, you can actually find out the changes. What if I want to expand? Okay, and what is the effect on? No,
I have a question.
Yes, Yuma.
I understood utilization and efficiencies formula, but use of them is how different?
Again?
How different utilization and efficiencies?
How different? What's the difference? What is the difference?
Yes, but when we use it, how different?
It is different because the concept is this. Okay, the concept is that
I understand.
Because we cannot use utilization. Utilization is not a good measure of capacity, effectiveness. Okay, a better measure is actually efficiency. So we must not just stop at utilization. You must calculate both utilization, because utilization will only compare with design capacity. Okay, so a better measure is actually efficiency. So any processes measure efficiency. Okay? Because efficiency will show the real one. Just now, okay, this one, for example, this one. If I make decision and say that actually utilization is low, but it's not about utilization. Utilization we say is low, but not really, because we have constraints, because effective capacity put into account constraints in our processes, such as just now new worker, for example, or even machine breakdown, because here it doesn't show how it calculates this number. Okay, design is 200,000, but actually we cannot achieve 200,000. Like I said just now, Proton car company can design is 150,000 cars per year, but he only can achieve 130, 140,000 because of why? Because of breakdown, because of plant shutdown, because of maintenance, year-end plant shutdown, year-end, at the end of the year, they do maintenance for 1 week, 2 weeks. So that is the reality.
So in reality, efficiency is more
accurate.
Good.
More good.
Decide.
Yeah, yes. Efficiency is much more accurate measure of capacity, basically.
Thank you so much.
Okay, no problem.
May I ask a question?
Yes, please.
If efficiency is better than the utilization, then why we
calculate utilization? We need to know. Because if you go back here, if you look at the definition of utilization. Okay. Utilization is a measure of our, these are, two different measures. One is compare with design. One is compare with design. Because we have a design capacity. We just want to have an idea, what is our utilization? Is effective. Utilization is also important. We cannot say it's not important, okay? It's important also. Because we invest, we pay for design capacity, When we buy machine, we pay for design capacity. We don't pay for effective capacity.
Because we don't know the effective capacity. If you
initially when we buy, when you buy equipment, you do not know the effective, because, for example, a maker of machine will tell you this machine can stamp parts 100 1 hour, but when we try out, only 80. So theory yes, but effective is another thing. But we need to know both. It is important. It is important because the nearer we get to design capacity, the better we are. So we need to, if your efficiency and utilization is very near, you are a very efficient company. You need to, the difference between utilization and...
Thank you.
No problem. So capacity is very important. Capacity decision impact all 10 decisions of operation management. Everything in operation management, including quality. Okay, quality will be impacted if you, have very, what do you call, high demand. Okay, you're rushing job, rushing. Then probably your quality will be affected. Okay, or even you will involve inventory. So it will affect all decisions in operations management. Layout, we will see layout next 2 more weeks, or the capacity decision will also be important to determine where you put your facility. Okay, and it must be integrated. It must be integrated with the company's organization, mission, and strategy. If you're a low-cost producer, you need to have high capacity. Then you find a place in which it is cheaper and low labor costs. That's why companies, they go and move their facilities. Japanese company, many in Malaysia, Shota, many in Malaysia. Beside my house here, there is a Japanese company. Stamp parts. Stamp parts? Stamping. Beside my house here. If you come to Malaysia, come to my house, I can bring you to the factory every day. So they move and find, and it must meet the mission and strategy. Okay. So there are considerations that all companies will, capacity consideration that all companies, operations will have to think about. Okay, like I mentioned just now, okay, we are in COVID. COVID resulted in some products high demand. For example, mask, face mask, high demand, correct? Or vaccine today, vaccine high demand. Not enough vaccine in the world, so they have to actually forecast, and also no time to forecast, no time to forecast vaccine demand. So capacity consideration, this you have to have a good forecasting, basically forecast demand accurately. You must match technology increment and sales volume. For example, companies producing electric cars, Tesla. So they have to actually try to match whatever capabilities with sales volume. Or even in China, now 5G. 5G is, everybody wants 5G, 5G technology. Do we have the capacity if suddenly sales volume goes up? So that is, companies, but if you increase capacity, demand go down, so you're going to face problem. Correct. I mean, you increase demand, increase capacity, but there is no demand. You're going to lose sales. So it is a very difficult balance. Okay, so you need to find the optimum operating size. Meaning that capacity must, this is perfect. Perfect. Capacity equal demand is perfect, but world is not perfect. So how to have optimum balance between your capacity and demand. And of course, the strategy is to build for change. Companies must always think about how to build for change. Like what I mentioned just now, I read about there will be a big, change in the economy next 4 or 5 years. How companies will, meet the demand of online learning. Now online learning, right? Zoom was sales go up after pandemic. Zoom, the Zoom, and also all the online platform. And they need to change very fast. So build for change. Right, so you need to move to think about, this is just a concept, okay? Just a concept about economies of scale and diseconomies of scales. So what is the size? You need to optimize the number of square foot in the store. If you're too big, now COVID time, too big store, no economy of scale. That's why they go for online, no retail store, but online purchasing. Correct. The Alibaba, or even retailers keep the stock themselves. So you need to balance. So what size is this? This is a small size. This is economy of scale. This is the optimum, basically, optimum size. Okay. So this is something that companies must always be doing the investigation and also doing the analysis continuously. Okay, concept. This is a concept only. It's a concept about big size store or small size store. Big size, no demand. You pay for rent, no income. No income. It's just what do you call cost? Only cost to the organization. Okay. Right. So some of the ideas that you can actually use, this is just suggestions or ideas. Managing demand, when demand exceeds capacity, again, demand exceeds capacity, you need to curtail demand by raising prices, but it's not good. Okay, you cannot curtail means stop. Curtail means to try to suppress or stop, lower demand by raising price or scheduling longer lead time. But the long-term solution is to increase capacity because demand exceeds capacity. Demand greater than capacity. If capacity greater than demand, you need to stimulate the market, sales, low price, because you have too many products or have product changes, new models, new designs, okay? Or adjust to seasonal demands. You need to have complementary, you have to have different product range. Product that is suitable for winter, summer, spring. So clothing will have different seasons. So they don't have to, they can complement demand patterns. Okay, demand pattern changes throughout the year, right? Especially for countries that have 4 seasons. Malaysia, no. Malaysia only have rain, sun. Rain, sun. No, no snow. Okay. No winter. Only raining season and sunny. Okay. So you can manage demand through these methods. Okay. Complementary demand patterns. This is the example. Okay. Company producing jet engine. They produce engine. So jet ski during winter. During summer, jet ski they play on the water, right? So snowmobile motor sales increase during the the months of what do you call winter. So you combine the two demand so that you reduce the variation. So in your company, your capacity will be able to be almost maintained. Okay, if you have 2-3 different product combinations. Okay, so that is also one kind of strategy that companies will have to consider, because they don't want to use the capacity, unused capacity. During the early time of COVID, many companies they change. For example, they used to make clothing, then they change into making medical, masks, all these protectors and so on. Okay. And other things. Okay, there are so many tactics or many ways of trying to match capacity to demand. Okay, making staffing changes, adjusting equipment, and so on. Okay, I mentioned this already just now. Purchasing additional, selling or leasing out, improving processes to increase throughput as well. This is continuously can be done. Redesign products. Okay, you have a few models, few variants, or even adding process flexibility. That means the process is flexible to be changed to the different kind of products. Okay, but of course this is also an option. Okay, this is also closed factory is also decision. Never discount this. Never say okay. You keep on trying to solve the capacity, but you won't be able. So close it. COVID. Close. COVID. I mean, no demand, right? COVID. Close. Okay, let me just a bit faster. Okay, in service also there is this demand management and capacity management. So demand management in service sector. So that's how they actually manage this demand. I mean, they have appointment system, reservation. All these are actually trying to make sure that customer in service, for example, you go to dentist, they have appointment because they don't want too many people to come at the same time. They cannot serve the customer, or they have reservations, or even first come first serve rule. So these are demand management techniques in order to cope for service sector, because service sector is much more fluctuation. Okay, changes. Or even capacity management in terms of take in a temporary staff, part-time staff. Okay, only a few number of full-time, but some temporary to adjust and to do that additional work, increase the capacity, basically, because you have more workers, you increase the capacity. Albaito, onaji, same. Restaurant, you go albaito, desho, wakaruka. So restaurant call, okay, today many people come. So that is service capacity management. The manager will have these spare workers, so they will call during peak hours, peak time. It's a lot of demand, a lot of customers, so they do that. Okay. Right. Okay, I'm not going to, I told you just now, okay, bottleneck analysis. Bottleneck is, there will always be bottlenecks in any system, okay? The bottleneck is the time of the slowest work machine. Bottleneck, you know, no bottle, there's a bottle, there's a neck. So it's bottle, slow down the flow, okay? Same, it's the same thing, okay? So the throughput time is the time it takes to a unit to go through production from start to finish. Okay, this is the throughput time. So the throughput time is 2 plus 4 plus 3, okay? This is storage, this is storage, this is storage, storage. The bottleneck is this. This is bottleneck. Immediately we can see. Why? This is 2 minutes. This is 4 minutes. This is 3 minutes. Why bottleneck? Every 2 minutes, I produce one. Second, 4 minutes, already 2. After 2 minutes, this fellow take this. 4 minutes. 4 minutes only, complete 1. So there's already 3, 4. Makaruka. So this is also in bottleneck. But here, take 1. So this is the concept. So we must try to, in production line, in car production, is that's why it's daytime onaji. Production. If you go to Toyota, is 1 minute, 1 minute, 1 minute, same. No, tech time. There's another concept. But this is the concept of bottleneck. So just to give an example, this is just an example. 2 identical sandwich lines have 2 workers and 3 operations. Okay, all completed sandwiches are wrapped. Okay, so this is the take the order. You go to McDonald's, you can see this. You go to McDonald's, you can see how the, you know, how many seconds to produce, fill, and then toaster, right? So you can see where it flows. Okay, wrap also in it, 37 seconds. So you can see that. So if you do the analysis, okay, let me see. Okay, clearly the toaster is the single slowest resource in the first, in the 5-step process. 1, 2, 3, 4, 5. Okay, toaster. Okay. So for throughput time, each assembly is identical. Should adjust. Suggest some the, okay, we are just supposed to total up the time, okay, for this process. Okay, is there some, okay, okay. So the 2 lines each deliver a sandwich each 20 seconds. At 37.5 seconds, wrapping and delivery has the longest processing time and is the bottleneck. This is the bottleneck. Bottleneck means problem. Bottleneck means problem area. Okay, so problem area, if you want to make it faster, so you have to reduce this time or have 2 wrapper, 1 wrapper, or maybe break down into 2 process. Okay, so rapid delivery has the lowest, the longest time. Capacity power is 99 sandwich per hour, and the throughput is 122.5 seconds. Why 122 seconds is the total, 30 plus 15 plus 20 plus 15 plus 20, 15? Soka. No. Okay. Do you know how to get this? 30, because there is 2 workers here, 2 workers. So 1 worker is daijobun, 13 plus 15 plus 15. So this parallel process, no problem. So the throughput is 30 plus 15 plus 20 plus 20 plus 35, 37. So it's throughput, it's just this flow. Because this is same time, 2 workers. The first worker do this, the second worker, so no need to add. No need to plus. So that's why it's only plus 15 and the throughput is 132.5 seconds. Okay, so it takes 132 seconds or 2 minutes to complete the sandwich. Right, so to improve this process, if you want to reduce the throughput time, you need to think about, well, order probably 30 seconds, this wrap and deliver need to be reduced. Okay. You can also do capacity analysis. Okay, standard process for cleaning teeth. Check in 2 minutes. Take X-ray 2 minutes. Develop X-ray 4 minutes. This is only theory, theoretical probably. Okay. So cleaning and examining X-rays can happen simultaneously. This is simultaneous. Simultaneous means that like just now, same time. Okay. But what is the throughput? Yusuke, what is the throughput? Throughput. What is the throughput? Throughput is the total time to complete the process. Or anyone else, or anyone who wants to tell me the throughput hour time, throughput time. It is what? Yong, or you may?
51 minutes.
How do you get 51?
Huh?
How do you get 51?
I totaled all minutes.
So you total the minutes. So 2 minutes plus 2 minutes plus
4
minutes. Okay, here what do we do? Plus?
24.
Yes, because we cannot take 5. 5 is lower than 24 because this time is required is 24 minutes. Plus 8 plus 6 equals to. So this is called throughput. Throughput. So you look at why your, your order come very late. When you go to a bank, why it is very late. When you go to a process, because of this, because of there is a bottleneck. This is so-called bottleneck. Any process has bottleneck. So how to do that? So you should find improvement of trying to reduce that time. But if it is, you shikatanai, shikatanai condition. For example, cleaning must 24 minutes. Sorry, so you cannot do anything. That is fixed hours. That is your call throughput. So that's the maximum possible. There is cannot shorten anymore because it's already the time, actual time required. Cleaning, slowly clean 24 minutes. Well, that is the, but you need 51, 4, 5, 6, 7, 8, 32, 40, 46 just all.
I make mistake.
You made mistake. Okay, daijoubu yo. Yu-Hong.
Yes.
How many minutes? 2 plus 2 plus 4?
56, I think.
46
46.
Okay. Daijoubu. Okay. 46. So 46 minutes to complete this cleaning process. Okay, cleaning process. So this is called capacity analysis. This is called capacity analysis. Simple. Sometimes we always want to use complicated method to understand things. Where we have a simple method which is useful, we should use simple method and do, for example, after this, take a new time, measure and see improvement. Kaizen. Okay. So X-ray pass is 27. They explain about X-ray pass and cleaning pass. It's okay. This is also another way of actually, we can use both ways to actually, there is 2 paths, 1 here and 1 here. So 27 minutes and 46 minutes. So the longest path involved the hygienist cleaning the teeth. The patient should complete in 46 minutes. Okay. And if they calculate the hourly capacity. That means in this cleaning, they can only process 2.5 patients. Okay, there is a station here. There is a, the cleaning place. So they can only make reservation for 2 patients. So this is how they determine the reservation for dentists, for example. Understand? So they cannot, you cannot book more than 3 people because the next person will wait long. You understand? Okay, so that's why the capacity, hourly capacity is 2.5. Okay, so that this is for scheduling purposes and for for that facility to know where they should actually what do you call schedule, do the schedule. Okay, right. Okay, let's take. Should I take a break? I don't think. Do you need a break? Let me explain this. Okay, this is. Then we can take a break. I think this is very important. I've already explained. I think I took too much time on that. So break-even analysis. Have you heard of break-even analysis? Have you done this? Correct. Correct. We did this before in our chapter, but almost similar. Okay, almost similar concept. Okay. So this is what we call as very important for any analysis for simple variable cost, fixed cost, and revenue, income. You want to produce a product A, product B, or process A or process B. So you have alternative. So it is a technique for evaluating process and equipment alternatives. Objective is to find the point in dollars and units which cost equal revenue. Cost equals revenue. Okay. And it will require estimation of fixed cost. So you need information, fixed cost. You need information, variable cost. And you need information of, the third information is revenue. And that means income. Income comes from sales price and unit sold or unit produced. Okay, so we'll see after this. Now, very simple. Okay, fixed costs are costs that continue even though units are produced. I think people in management should know this. Fixed cost, depreciation. You should know. No question about this. And variable costs, things that you produce, volumes of unit produced, it varies by the amount they produce. So this is a cost that vary. For example, if I produce 1 unit, okay, I have material, I have labor, I have utilities, electricity, water, okay, and contribution for these units that you sell or produce is the difference between selling price and variable cost. That means every unit selling price minus variable cost is the contribution, okay, to the revenue. Now, not contribution revenue, to the variable cost. Okay. Now revenue. So revenue is income. It begins at the origin. That means it begins when you say origin, it means here graph. Okay, graph is origin 0, x0, y0, and proceeds outward to the right, increasing by the selling price of each. There is a revenue line. Okay, revenue line. That means if I have 100 units and I sell it at $10, I will get $1,000. Okay, that means this is 100. Then my income is going to be 1,000. Correct. Okay, so this is revenue line. 50, of course, some value. 10, 20, 30, and so on. So where the revenue function cross the total cost line, so this is revenue line. But if I have a total cost is fixed cost plus variable cost. Okay, let's say we have a total cost and fixed cost, this line, somewhere here. So this is total cost. So this is the break even. Break even. So think break even. No profit, no loss. No profit, no loss. Okay. Initially loss because cost higher than revenue. Loss. Loss means no income. Loss. Okay. So this is the concept. Same concept. You see here? You see here fixed cost. This is fixed cost. Why this straight line? Because it is fixed cost. How many you produce? Same. But variable cost depend on the volume. The more you produce, of course, the higher the cost. And you have your total revenue line. This is the loss corridor. That means no income here. No income. Okane nai. Okane loss. This koko kara okane morao. Koko wa break even. Tabu ni takutaru ne minasan. Kita kutaru ka? Mita kutarimasu ne. Okay. Mo ikai revise. So this is concept, very simple concept. But now because of this, because we know fixed cost, we need to make assumption. This is assumption. But this is a very good assumption. It is real. It's not in the case in the real world, but it is the best assumption, which is linear. Minasan, you know linear? Linear wakaru ka? Linear. Linear is a straight line. Linear. That means linear function, straight. Korewa linear janai. Korewa. So we assume linear cost and revenue. And we actually know the cost, but it's very difficult to verify. But it's the best estimate. Best estimate. Better to have some assumption and close to actual than to have no assumption. No numbers. How to calculate? Dame. So this is the best. And also we forget about time value of money. Time value of money is ignored. Time value of money, future value, because of interest rate change, money change, the value of future. This is constant time value of money. So that is our assumption. So this is the tricky part. Okay, it's just names. Don't worry about this. This is BEP, break even point in units. Number of product. Okay, break even point in dollars. X is the number of units produced. Revenue is price. Okay, P, price, times volume, PX. Fixed cost is fixed cost. V is variable cost per unit. V is variable cost per unit, and TC is total cost, which is F plus VX. Okay, so the break-even point occurs when TR equals to TC, or because TR is PX. Okay, so this is PX. So break-even point for X, which is units, is equals to fixed cost divided by contribution. Okay. Just now we say price minus variable cost is contribution. Price per unit minus variable cost per unit is contribution. Okay. So we have this formula. You don't have to memorize the formula. You need to understand the formula. Only understand the formula. Okay. Not memorize the formula. Okay. So this is an example of given values, okay? Value value. Fixed cost is 10,000 unit, $10,000. Direct labor is 1.5 per unit. Material is 75 cents. Selling price is $4. So you can find the break even in terms of dollars to be 22,000. F divided by 1 minus V over P. So you'll get 22,000. And the break-even point for units, X, is 5,714. So anything that you produce before 5,700 is loss. Anything that you produce beyond 5,700 is going to be profit. Okay? So that's why you need to understand that, you know, and you plot this. Okay, you need to plot this. So this is 5,714. Okay, and this is 22,000. So it's nothing but showing these 2 points. One here, this is BE break even point dollar ka, dollar. This is break even point X ja. Okay, so these 2 points. Right, so there's a few more things that I need to explain to you. This is a very simple, straightforward one product. Okay, one product. So you can also do analysis for multi-product. It's a little bit more complicated, but it can be done. Okay, it can be done. So the formula is just adding another, you know, formula. Okay. So multi-product case, this is actually if they put in weights. Okay, this is percent each product of total sales expressed as a decimal. Okay. Let's see this example. Okay. So this example is sandwich at this price. So this is the price. Okay, price for sandwich. This is the variable cost. This is the projected sales. And these are the 3 different products. Okay, 3 different products with the price and the cost. So the question is trying to find the break even. Okay. So each item has its selling price, and there is a contribution V over P, 1 minus V over P, and this is percentage of sales. Okay, percentage of sales, and it will give you your weighted contribution, which is, for example, this is you see here, column 5 times column 8, column 5, which is column 5 times column 8. So you'll see here weighted contribution for different products. So this is when you have multiple products that you need to determine what is the best combination to break even, basically. Okay. So using that earlier formula just now. So if you use earlier formula just now, fixed cost is 3,000 per month. So it's already given. So you still need fixed cost, you still need variable cost, you still need the price. The only thing added here is actually the percentage of sales and the weighted contribution. right? Miruka. Okay. So the daily sales from this break even $4, okay, $245.50 using that formula just now, and also the daily sales of 30 sandwiches per day. Okay, so the break even. In order to have this combination and the expected sales, basically. So this is for multi-product, basically for multi-product, and you want to know the best combination of these three different products. Okay, so this is shown in what do you call the example in the book as well. Okay, never mind. I'm not going to be worried about this. It's there. Okay, it's there. If you need to do this analysis, you can just refer and apply this. Okay, right. Okay, I'm not going to explain all these other things. So if you can, if you can go to the end of the chapter of the textbook to problems, I want you to try and solve problem on page 368, problem S7.6. S7.6 and also 7.17. Okay, let me just open the book, if I can open the book. Okay. So this is a big, when let's say single product, multiple product. Page 368. Okay, problem 7.6 is actually the effective capacity, and if you have a spreadsheet, you can actually do break-even analysis. But you need to understand, I do not like to teach. When I teach, I do not like to teach Excel directly, because there are Excel and you can just put in the formula, I know. But it doesn't help if you do not understand the workings behind it. That's why I don't like to show directly Excel. This is automated calculation. You can put it yourself. It's not a problem if you understand how to do it actually. Because Excel is powerful. I'm not denying it. Okay, Excel, you can use Excel, but you need to understand this first. You need to understand these basic formulas before you can actually put into Excel. So I don't like black boxes. Black boxes, black boxes? Black boxes. I don't like black boxes because it's not helping, because you need to understand, you understand the fundamental, then you can actually go for So if you can do 7.6 here, the effective capacity efficiency for next quarter at MMU manufacturing for each department is this so-called compute the expected production for next quarter for each department. Okay, that's problem 7.6. If you are, if you want to know more, you can do by yourself. You can do other problems which relates to that capacity. But this one, no, I'm not. If you want to try, you can do 715, which is also a good, 715 here, 715. Mieru kana, Mieru, minasan? Mieru? Yeah,
Yes.
716, 7, okay, so 77, 77 ka? 76, 76, S76, S7.15, and also try to do, this is very simple on this, just one product, okay, one product, which is actually S717. So these three problems, if you want to do it, you can start doing. Well, we also finish our class, almost finish our class. You can start doing it if you want, or we can finish our class. You can do it by yourself. And as usual, I need you to submit this.練習だけ優しいよ。大丈夫でしょ。あ、ファンギー、大丈夫でしょ。大丈夫でしょ。
It's okay.
Okay, so I'm actually I'm not feeling very well. I'm not, I'm not. 私はちょっと病気が some sickness, okay. でも大丈夫。So I want to leave you for the class. So I've covered very fast today. A lot of calculation. No video today. Or you want to see last video? Okay. You want to see video? Or no need video? Today no need video for you to. So you try these three questions and do it yourself. Please do it yourself and try to understand. And if you have opportunity to use it in your condition, your work. I've done break-even analysis. I give an example, real life example. I conduct course training. So I want to know how many participants break even. I conduct course training course. How many charge revenue? I charge 500 ringgit per person. It's a 2-day course. For example, training on how to implement ISO 9000 in company. ISO 9000, ISO 9000? Yes. Have you heard of ISO 9000 quality system? So I will calculate the variable cost. Variable cost for notes, printing notes, for food, one participant, food. So all these are variable costs. Fixed cost to rent the room, to pay for the hotel. So fixed cost. So I calculate break even. If I want to break even, I need, finally, I calculate 20 participants. If not, I don't run the course. If not, I do not run that short course. So you can do for many things, break even for many things. Okay, you think about what is the fixed cost, variable cost. I want to run this, and until you get that number, you are running at a loss, or you give discount. Okay, so you have to think about this revenue, early bird price. You know early bird price for conference. Early bird means those who register very early. This price. After this date, increased price already. Conference, you go conference, international conference. Early bird, first before 30th of August, the fees is $500 US dollars. After that is $800. So you can calculate your income based on the different pricing strategies. Okay. So break even is a very powerful, simple but powerful.
Last spring,
Yeah.
I helped my father's company and calculate break-even point. So it's
Very
was
good. Very
very hard.
good. Yeah.
But
Very
it's
hard.
hard because I have to decide what is variable and fixed.
Yes.
Very difficult to.
But it's okay. Don't worry, because it's not exact, must variable, no need. It is as close as possible. The most important is as close as possible. Yeah, decision of variable, assumption, you have to decide. This is fixed. This is fixed. Good, very good. So you can share with your friends. Shota can try and do. This is simple, powerful. It will. You can continue to use this for the rest of your life. Okay. Yeah, minasan. I think we stop here. Kokomade orimashou ka.